Does anyone want to start? Any
Can
questions?
we just like start from the beginning and go down? Maybe not number one, but like to number two.
Okay. Number 2 is a little tough, and it was like there's another one on here. Number 2 and number 8 are very similar. And this is one that I had on the board and I talked about, but it was like right at the end of class. So I think everyone was just like kind of over it. The difference on number 2 is that I tell you at what pace that person is walking and then for how long. I didn't tell you the distance. So we had to transfer like pace and time into distance. So it says she's walking at 3 miles an hour towards this building. And at one point, her angle of elevation is 11. And then as she gets closer, her angle gets bigger to 13.5. And the distance here is 15 minutes worth of walking at 3 miles an hour. So I had to do a little conversion in purple first. So I had to do, okay, 3 miles over 1 hour. And I had to see how long she was, how much that was for 15 more minutes. Now I've had students in the past that don't necessarily need to do a conversion. They're like, okay, well, 3 miles an hour means that like in 1 hour, she should walk 3 miles and we're doing a quarter of that. So a quarter of 3 is 3/4. So that's how we got 0.75 miles. I can't think like that. So I had to do conversions. Once I did that, let's break it down a little bit more. I labeled my picture here. So my distance at the bottom is 0.75, and then D I put from where she's standing to the building, and then H is ultimately what we want to find. So what I had to do was think about them in different triangles. So I'm going to think about like this triangle first. This triangle is tangent of 13.5 equals opposite, which is the height, over D, which is the adjacent side. And all I did there was solve to get H by itself. Now I got to look at the other triangle, which is like here. And again, we don't know how to deal with non-right triangles. So everything we've done so far is right triangles, right triangles. So now this has a angle of 11. It has an opposite of H, and then its like adjacent side is D plus 0.75. So that's why over here to the side, I've got tan of 11 equals H over D plus 0.75. I did substitution. So I replaced that H on top of that new equation I just wrote with D tangent of 13.5, but it looks like I actually found out what tan of 13.5 was. I just made it a decimal. So you can also do that. I think most of the time I was making us like work through it. I was like, okay, carry like your tan 13.5 all the way through. You can also put tan 13.5 in your calculator whenever and then solve that. Same thing as it looks like I did tan 11 at some point in my calculator and got 0.914. And then now I just have a bunch of decimals, and that might be easier to kind of deal with and play around with.
I think my biggest question here is like, how do you know that the triangle is split in two?
Because we're looking at a building. So we're always looking at the height of the building. And she starts standing here and then she walks closer to the building. And then we do a new angle. So since I've got a new angle, I've got a new line going up to the top of the building. So if you talk about like standing somewhere at an angle and then walking closer and being at a different angle, then you have that line down the middle of my triangle.
And is there going to be any on the test that have to do with 3 miles per hour?
I truly haven't looked at the test yet. I don't know. I don't know if I did or not. I hope I gave you distance, but we'll look and see what I did. I put 2 on here like this. So if you look at them and see if you can kind of reason your way through, you should be fine. I think the hardest part is not the distance right here. It's the like two triangle part. So I wish I could give you a yes or no, but I don't know yet. I haven't looked at the test.
It's okay.
All right. Anybody else questions on this one? And then some of you guys, when you were doing it, you got the right answer. You got like your 0.76 whatever, and you're like, that can't be right. But remember that that's not in feet. It's not 0.76 feet. That's in miles. So since I kept this in miles at the beginning, then my height now is in miles. Now we never say, somebody is point something of a mile high. So that doesn't really make sense in our head. So you could transform it to be in feet if you wanted to. So you could do your 0.7674 times 5,028 or whatever that number is feet and get that number in feet if that makes you happy. But yeah, kind of a weird problem. Anything else with this one? Okay. The next problem has the common mistake here was that we were in different units. So it says find the angle of depression from an airplane that is 2,000 feet above ground and needs to land at an airport that is 2 miles from the airplane. So a lot of people want to put the 2 miles down here, but that's not right. It's from the airplane. So the airplane's up in the air and this is the airport. So we got to do 2 miles as that like slant distance. Now the problem here is that you cannot do a ratio with feet and with miles. So you need them both to be in the same unit. So I chose to put 2 miles into feet. So I converted that. So 2 miles is the same thing as 10,560 feet. And then I was able to do my ratio.
How many feet are in a mile again? I feel like I should know this, but I just don't off the top of my head.
1 mile is 5,280 feet, I think.
Yeah, that sounds right.
I know those
Thank
are the
you.
right digits. I think that's the right order. Yeah. Cool. Any other questions 1 through 3? Okay. Number 4, I did weird. I'd probably put 27 down here and do sine of 27 equals 18 over x, but you should get the same answer. Again, it says how far is the squirrel from the nut? And so that's not the horizontal or the vertical distance. It's like the slant distance. So half the battle is drawing a picture and identifying correctly which distance you have. All right. Any other questions on the front page of this?
What's the difference between the angle of depression and the angle of elevation?
They're technically the same thing. They go in the same spot. It's just on how you look at it. So the angle of depression is like when you look down, and the angle of elevation is when you're looking up. But because your line of sight is parallel to like the ground, those angles get to be the same. So technically there is no difference. You can just put that these two angles should be the same. So angle of elevation or angle of depression go in that bottom corner. The one mistake I've seen is people try and put it here, and that's not right. That's no angle. The 63 doesn't mean anything. Now, this is a 90-degree angle, so I found 63 because I knew 27 minus from 90 is 63. But I think it's easier to just write every angle down here in the corner and call it a day. Does that help, Hadley?
Thanks, Miss White.
Bye, Brooke. Sorry I got on late.
It's okay, thanks.
Bye. All right, should we go to the second page? Remember sinusoid means that the period is the same. So period for any sine and cosine is 2 pi. And then if there's something in front of x, then we do 2 pi divided by that. So these should be pretty easy. I'll give you something like this and I'll say, is it a sinusoid? And you look at the period, you say yes or you say no.
Wait, can you explain how you figure that
Yeah,
out?
I was gonna ask, could you explain that again, please?
Okay, this uses the period, which we've done a lot. Period is 2 pi over b. And b is like whatever's in front of x. So like there's nothing in front of x here. So your period is just 2 pi. If the period is the same for both pieces, then we say yes, it's sinusoid. If it's not, so like on letter D, I've got 2 and I have 4. So for the first period, I would do 2 pi divided by 2, that's pi. For the second part, I'd do 2 pi divided by 4. Well, that's pi over 2, that's not pi. They're not the same, so that's why that's a no. I don't care if there's any number in front, that's the amplitude, that does not affect the period. So the 2 and the 1/2 don't matter, or like the 1 and the 5 don't matter. It's just in front of the x. So like on letter D, I've got 1/2 in front of 1x. So pi over, or sorry, 2 pi divided by 1/2 is 4 pi. And then I've got 2/5 in front of the other one, and 2 pi divided by 2/5 is 5 pi. And those are not the same, so that's no.
For ones like E, which like it's obviously yes, because it's the same number, like, do we have to show work?
I would just show work or be able to explain that they have the same period, or you know what I mean? There's just like,
Yeah,
and be able to show me why.
okay.
On my study guide, all I put was yes and no because I just like did it in my head. Is that okay?
On your study guide, that's good. But if on the test, I say like explain
Yeah.
or tell me why, just tell me why.
Okay.
All right, let's look at 6 and 7. And then 8's a lot like number 2, so we'll look at that one again. I thought 6 and 7 were pretty self-explanatory. Tan is the most common trig function that we're going to use because often we have like a vertical distance and a horizontal, or we have an angle and either horizontal or vertical. Wanting the slant distance is kind of a weird thing to want. So tan is usually what we use. And also remember that if we're looking for the angle, you have to do tan to the negative first. We have to do second tan. If you have tan, if you have an angle, then you press normal tan and then type that angle in.
Wait, so for number 6, it's like you're trying to find the slant. So you would use tan. No, you're trying to find the angle. Okay, wait, never mind. Sorry. I got it now.
Good question. Anything else on 6 or 7?
In your calculator, would you put it in degrees?
This one I would, especially because all of the things I'm usually putting in are degrees. So like 28 is degrees. So make sure that that matches. On like number 6, you could answer in radians, but we're not used to that. So I would probably put degrees because that makes more sense in my head.
Okay. Thank you.
You're welcome.
Are like all of the word problems split like in degrees?
Yes. We don't really think about like word problems in terms of radians. Like if I was like, pi over 2 radians to your right, you'd be like, what does that even mean? But if I said 90 degree, like a 90-degree turn, you'd be like, oh, I know exactly what that means. So I would just generally keep it in degrees, but know how to switch out if I ask specifically about radians. I'm going to scroll down so we can also see 8. 8 is a lot like number 2. So she's walking towards a building at a pace of 2.5 miles per hour, and she does that for 20 minutes. So when I converted that, I got that she had walked for 0.833 miles.
That goes down here.
It says at one point her angle of elevation is 18 degrees, so that's where she starts. And then she walks for that 0.83. Oh, I don't know why I have 8.3. It should be 0.83. Hope I didn't screw that up. I think we're good. So she walks for 0.83 miles, not 8.3 miles. And then now her angle of elevation is 68. So now we've got, again, 2 triangles. So I did tangent for the first triangle. Tangent of 68 equals h over d. So that's this inside triangle. Again, if you're standing somewhere and you have an angle and then you walk closer and you have a new angle, that's a sign that the triangle is going to look like this. Another example we did like this was like a car drove closer to the building. So think about if something happens twice, like if you're somewhere and you look up at the building and then you get closer and then you look up at the building again. So I use the orange for tan of 68 equals h over d. And then I'm going to do the bigger triangle, which is the whole thing. This right here. And that's an angle 18. So tangent of 18 equals h over d plus 0.833. Question?
So we do the left triangle first and then the whole thing?
Yeah, think about the small triangle first and then the big triangle.
Okay.
Mhm. And then I took that small triangle and found just h, and then I substituted that into the other triangle. Think about this. We have 2 variables here, and I need to substitute in order to use them. I can't just use them by themselves. I can't solve this all the way down and get an answer because I've got h and d. I can't do that. Same thing over here. I've got h and d. I can't just simplify down. So you have to substitute one in. And again, this one, since I was in miles, my answer was 0.317 miles. So if you get to a problem like this, think about, okay, well, we can make that into feet, or I'll accept the mile answer. That's totally correct too. It might not make sense in our heads, but it's not wrong.
Wait, I don't think I did the big triangle like different than you. Or maybe I don't know, but like what I did when I was doing the whole thing, so I did I did 18 and then on the bottom I put 0.83 plus x. And then for the equation, I did tan 18 equals, and then I put in on the top what I found for h, like I substituted it in, and I put x tan over 68 over x plus 0.83.
I think that's okay. So what you're,
But I don't think I got the same answer as you because oh wait, yes I did. You just did more than me.
that probably happened.
Yeah, I only did 2 decimal places.
Oh yeah.
I
then-
put 0.13, but that's the same thing as you put.
Mhm.
Never mind. But why did you do it that way? I don't understand how you did it.
Like, how did I get like this decimal?
Yeah.
It looks like I plugged in tan of 18 like super early. So as soon as I like wrote my equation, I plugged tan 18 in my calculator and I just made it a decimal, and I just carried that decimal with me the whole time.
Oh, okay.
Same thing with tan of 68. I did like that and I got 2.4 blah, blah, blah. And I like brought that with me the whole time.
Yeah, I just waited till the end to do that.
Yeah, that's probably cleaner. This looks a little messy, but some people also get kind of freaked out with like the tangents involved, and they're like, okay, well, if I make it all decimals, I know I can work with decimals. So that's definitely an option too.
Okay.
You sound like you're good, Ava.
Okay.
I'm confused where your numbers came from after you did tangent of 68. Like, where did the 0.1259 come from?
0.1259. right here. It looks like I solved for D. And when I solved for D, I got this number. It should be the same number I would get if I plugged, let's see if I carried this through. So like tan of 18, and then this would have been like X or D, tan of 68 over D, or sorry, X. So if I had not like done decimals, I should have gotten this in, and then I would have solved to get X by itself. So I would have had like tan 18 times X plus 0.833 equals X tan of 68. Oh, and then I have to do all this work to get my X's together because I forgot I had an X on top.
Would you mind like going from the very beginning of this problem again?
Like you want me to just do it all the work out again?
I'm just like confused where some of the numbers are like coming from.
What
I
did
get it, like in the steps on how to do it.
What'd you plug in to get like your D or your X, that value that went right here?
Like I don't even know, like I just had tangent of 68 and then I don't know where to go from there.
Okay, well, you have to write two equations. That's half your battle. I don't want to erase all of this. Oh, I can't erase it. Okay, that's fine. Okay, so you have to start by doing your small triangle. So I've got this guy right here. And so that means I've got tan of 68 equals H over D. I can't solve that though because I've got two variables. So the minute I see I have two variables, I need to look at the big triangle now. So now I'm going to do tan of 18 equals H over this whole denominator, or this whole bottom. Tan of 18 equals H over X plus, or D plus, I keep changing my variable, 0.833. So again, we can't just do like this long skinny triangle. We don't have the tools to do a not right triangle. So we have to use the right triangle. And so if I've got 18, my opposite is H, and then my adjacent is D plus 0.833.
Okay, totally get that. I just, for some reason, thought you had to solve the smaller triangle first to get to the bigger triangle.
We have to simplify the smaller triangle in order to substitute it in. So I want to get one of the variables by itself, and it's easiest to get H by itself. So if I do D tan of 68 equals H, now I can replace this H with D times tan of 68.
Okay, okay.
And then now it's going to be some algebra, but now I have just one variable in here. Now my only variable is D. Before I had H and D in both of these. There's H, there's D, there's H, there's D. Now I just have two Ds, and I can solve now because I can simplify that. Now the algebra is going to be a lot right now, so I hope I've got enough room. But I'm going to cross multiply, and I'm going to do D tangent of 68 equals, and I'm going to multiply my tan 18 by D and by 18, or 0.833. So I've got D tan 18 plus tan 18 times D. I'm running out of room. I need to write much smaller. D tan 68 equals D tan of 18 plus 0.833 tan of 18. Pretend that says tan of 18. And then I need to get both my D's on the same side. So I'm going to move the D tan 18 to the left side. So I've got D times tangent of 68 minus D tangent of 18 equals that 0.833 tan of 18. At any point, you can put this in the calculator and you can get one number for 0.833 tan 18. If you're like, I'm getting confused carrying this through, the minute you multiplied them together here, you could have done tan 18 times 0.833 and gotten a decimal. I don't have my calculator with me, so I can't do that right now. But the next thing I'm going to do is factor out a D from the other side. So I've got D, and I've got tan of 68 minus tan of 18. And again, you can put that in your calculator at any point and get a decimal there. And again, it's going to equal whatever the decimal of 0.833D is. And then we divide the decimals by each other. So you just can't put variables in the calculator, but any other time, like anytime you saw tan 68, you could have made that a decimal right away. And then once we find D, then I plugged that in right here in the first one. You could have plugged it back into the second equation, it doesn't matter. But I thought this was pretty easy to finish solving. So I did tan of 68 times this decimal and I got my H. Does that make a little bit more sense? Okay, cool. Anybody else questions or concerns on this problem? I know we did at least one or two, like the car one like this on your notes. You can go back and look at that too. This is definitely the hardest type of problem where it's the two triangles. I think a lot of the rest of this test is pretty self-explanatory. We've done word problems with Triggs before. Sinusoid is really not that hard once you remember what you have to do. And then this 4.7, I'm letting you use your unit circle, so that should be pretty simple. Any questions on the first 2 pages? Let's go to the last 2. So there's not really a lot of work here, and that's kind of what I expect on your test. It's kind of right or it's not right. The only thing that might be a little confusing is that I'm using like the negative signs. Instead of saying like negative pi over 4, you could have written, I think 7 pi over 4, and that's the right answer too.
So we don't put the angle.
Oh, these are angles. I chose to write them in radians. You could write them in degrees too.
Yeah, like
90,
I put 90 degrees and pi over 2.
315. Yep, you can do that.
Yeah.
45.
Okay.
Mhm.
Would you prefer one or the other, or like both, or does it really matter?
If I ask on the test, if it says like write in degrees or write in radians, match it, especially because you have your unit circle. Radians, I think, is like the most correct math, but like degrees is also okay. So I'll tell you tomorrow on the test, or else I'll accept both. The biggest thing is see the difference between where I have like the -1, which means my answer is an angle, versus when I just have normal sign and my answer is like a number, a ratio.
Yeah, how did you get, I'm confused on that section, that second section.
Yeah. On like which one? All of them?
Yeah.
Okay. Well, this is just normal sine, cosine, etc. So sine of pi is your y at where pi is. So what's your y at pi?
My y at pi is, it's 0. Oh, so we're looking at the, okay, I get it.
The other 3 were like cosecant and secant. So you have to remember that cosecant is 1 over y. So y at 7 pi over 6 is -1/2. So you have to like flip it. And then same thing with secant, it's 1 over x. So you had to do a little flipping there, but.
Okay.
Miss White,
Yeah.
I was on retreat when we did all this, so like this is like Chinese to me.
This
I have no idea what I'm doing.
4-7 stuff.
I get like the word problems and like sinuside and stuff, but when I like this back page, what we're looking at right now, like I don't know what I'm doing.
Okay, do you have your unit circle?
Yeah.
Okay. So this first part, if I say any trig function to the -1, it means that I'm giving you like the x or the y or the ratio, and I want my answer to be an angle. So like I said, cosine -1 of 0. So that means I'm looking at the x The X value I gave you is 0. So what angle has an X value of 0? And if we went to our unit circle, we'd go look and we'd say, okay, the only place that has an X value of 0 is 90. The one thing you need to know is there's only a couple like places that we look. So like sine and tangent, you can only look in quadrants 1 and 4. And then in cosine, you look in quadrants 1 and 2.
Okay, that makes sense because I saw 270 and I was like, that has an X of 0. So why isn't it that?
Yes.
But that
Good point.
makes sense.
Good point. So we only want one answer. So we're only looking in quadrants 1 and 4. Same thing for like the next one. It says sine to the negative first of negative root 2 over 2. So we're looking at the angle. So my answer is going to be an angle. And I want to know where the sine or my y is negative root 2 over 2. And so again, I wrote it as negative pi over 4, but I was really stressing something that year. If you went to your unit circle and you went to 7 pi over 4, you would see that the y there is negative root 2 over 2.
So the -1, all that means is an angle. It's nothing more than that.
That means -1 means your answer will be an angle. Yes.
Okay.
And then can you remind me what, like 5, 6, and 7? Can you remind me of that again, please?
So this is the stuff that we have been doing. So this is where I give you the angle and I want a ratio out. I want like a number out. So like if I have sine of pi, you're going to go to pi and you're going to say, okay, what's the sine or the y value at pi? So this was like what I made you do with that unit circle quiz over and over and over. I can throw you some harder ones where I give you like secant, where we have to do 1 over y, or I can give you easy ones like sine and cosine, where it's just a search and find. Anything else on this page?
I have a question on 15 and also 14 and 16.
Okay. 15, 14, and 16 are composite functions, which means that I'm doing one function and then I'm taking that answer and doing another function of it. I've got a function inside of a function. So if I look at 15, technically I have to do sine to the negative first of root 3 over 2, and then I'm going to take that angle and do the cosine of that angle.
I was confused because it wasn't like parentheses, so I
Yeah, I
don't know.
don't know why that one didn't have parentheses. But here, so even if anybody else doesn't know how to do this, I'm going to start by looking at where my unit circle, where's my sine or my y, positive root 3 over 2. So my y,
5 over,
say again.
5 over 6?
I think it's,
Oh, wait, no, that's cosine. Never mind. That's wrong.
yeah, it's the other one.
Pi over 3.
There you go. Pi over 3. And Grace, you did a good job catching yourself because we remember cosine is x, sine is y. So that's a really easy thing that like I get messed up sometimes if I'm going too fast. So make sure you slow yourself down and say, okay, am I actually doing what I'm supposed to be doing or just finding the first root 3 over 2? Now, I know that that inside became pi over 3. Now I'm asking myself, what's my cosine at pi over 3? And remember, cosine's my x. So what's my
But
x?
what if there's another sign with 3 pi over 2 though? So what if you put that one? Like,
There's,
how do you know which one to put?
remember for my inverses, it has to be in quadrants 1 or 4 for sine.
Oh, that applies here too.
Yep.
Oh.
Is this like another way to do it, like instead of what we did in our notes? Like, is this like an easier way?
So the way that we did in our notes where I drew a triangle out.
Yeah.
The way this is easier because this is actually a unit circle problem. The ones I think I gave you in our notes were not unit circles. They were just random like ratios. It was like 4 over 5 and like 1 over 10. This
Okay.
is like actually on the unit circle, so we don't have to draw a triangle out.
Okay.
Good question, Liz.
So then would that just be 1/2?
Uh-huh.
Okay.
Can you do one with like cosecant or cotangent or something? Like either 14 or 16?
Let's do 14. So it says cosecant of 1 pi over 2. So cosecant, does that go with my x or my y? Let me rephrase that. Does cosecant go with cosine or with sine?
Sign.
Sine. And then is sine x or y?
Why?
Y, good. So we're essentially doing cosecant is 1 over y. So what's my y value at pi over 2?
One?
1. So cosecant of pi over 2 is 1 over 1, which is just 1. So we just use the y as the denominator and we just did 1 over that. It just happened to stay 1. So now I'm doing inverse sine of 1. So I'm asking myself, at what angle is my sine 1? And I have to remember sine is y. So where is my sine, or where's my y, or where's my sine 1? What angle?
Pi over 2.
Mhm.
90.
Or 90. Mhm. So think about, let's do the inside, and then once I solve the inside, we're going to take the outside of that new answer.
So is this like all the same on this page and the back page? Like it's all the
Yes.
same stuff?
It's all just mixed in together. Yep.
Okay.
I tried to give you just a bunch of examples because I feel like this isn't like hard. Like we'll walk through one and you might be like, oh yeah, I get it. But like I think that by doing several of them help you like really get it, or kind of go through the motions of finding stuff.
Could we do number 16, please?
So number 16 says cotangent of 3 pi over 4. So cotangent is x over y. So we need to go to 3 pi over 4 and find out what my x is and find out what my y is. I believe that's one of the 45-degree angles. So I think it's at root 2 over 2 over root 2 over 2. And I think since it's 3 pi over 4, the x is negative. Are we okay with that? Everyone finding that? Okay, so now I multiplied. This is ugly, so I've got negative root 2 over 2 times 2 over root 2. Cross those out.
Yeah, I was gonna say, is it just -1?
-1. Mhm.
There, that's
So that whole inside becomes -1. So now I'm doing inverse sine or second sine of -1. So I'm asking myself, okay, what angle is my sine or my y -1? Now, when I did this in the past, I was worried about like negative angles, but like for now, we would say it's at 3 pi over 2 or 270. All of these angles are the same. It's not like one is more right or wrong than others. It's just in different years, I've kind of stressed different things. But the only place where y is -1 is at 270.
So is that like an exception when you're looking at like just quadrant 1 and 4, since that's quadrant like 2?
So 270, I think, is between 3 and 4. And so I would still count it. Since it's at
Oh,
the bottom.
yeah.
Mhm.
My
No.
brain is not working.
That is my question.
No, you're okay. It's right at the edge. 90 and 270 are kind of right at the edge, so we include them. Lex, did you have a question?
Yeah, that was gonna be mine. So there's like 3 pi over 2 and like those two angles, the ones that are vertical, do those go with like either like the top one, does that go with 1 or 2, and then the bottom one goes with like 3 or 4?
I would kind of like, if they touch the quadrant, I would count them. So like I would count like this one at 90 to be in quadrants 1 and 2. And then same thing with 270. I would count it in 3 and 4, kind of depending on what use we need for it. All I know for sure is that like this, like the 180 is definitely not in quadrant 1 and 4 because it doesn't touch it. Does that help?
Wait, I'm confused.
Yeah.
What's negative pi over 2? What is that? Is that an answer or?
Yeah, it's an answer. So negative angles mean that we went backwards from 0. So instead of going up pi over 2, we went down pi over 2, which is at 3 pi over 2.
Oh, okay, I see.
Just another name. All right, what else can we do?
Can I see the answer for 19?
Uh-huh.
Okay.
All right, what else can I help you with?
Can you do 24?
Okay, so this is another one of those negative angles. If you don't like seeing negative pi over 4, think about going like backwards pi over 4 this way. And that would be the 45-degree angle in my quadrant 4. So that's either 315, or you can think of it as 7 pi over 4. So it says we want to do tangent of that. So tangent there is always y over x. And we know that it's at a pi over 4, which means, or 45 degree, which means the x and the y are the same. So I've got root 2 over 2 divided by root 2 over 2, or times its reciprocal. It's negative y. So my 2's and root 2's cancel out. So that inside tan of negative pi over 4 is negative 1. Everyone okay with that? So I made the inside just be negative 1. Now I get to do inverse or second cosine of negative 1. And so I ask myself, okay, what angle has an x of negative 1? And the only angle is 180 or pi.
So there's gonna be negative ones on the test.
Again, Ava, I haven't looked at the test. I can go back and make them not negative. I just haven't looked yet.
Yeah, because I'm gonna I don't know. That still really confuses me.
We just go backwards. Just go backwards of pi over 4.
Well, like, how much is pi over 4?
Well, how much is it in the first one? And how much is pi over 4 in the first quadrant?
Oh, okay. I see what you mean.
Mhm. I know we don't often go back there, but it's all just like they're all increments of the same. So like pi over 4 is 45 degrees no matter where you're at. Same thing, pi over 3 is 60 degrees no matter where we at. All right, what else can I do?
How is 23 pi over 2?
It is not. It's pi over 4. I knew there was a mistake somebody caught, and I hadn't changed it. Pi over 4.
Miss White, I'm gonna go, but thank you so much.
You're welcome. I'll be
And
around
I'll be
tomorrow
around.
morning if anybody
Okay.
needs help.
Perfect. Thank you.
Thank you, Miss White.
You're welcome, Grace.
Thank you.
You're welcome. Bye, Hadley.
Thank you so much.
You're welcome, Cleva.
Thank you.
Bye, Ava. If anyone has any more questions, I'll stick around, but if we're all kind of finding a natural ending place, we're free to go. Lex, you got any more questions?
I guess not.
I'll be
I just
around.
need
if-
to do it.
You what?
Well, I didn't finish it, so I don't really know. So I'll just have to do it and then see if I have questions later.
Okay. If you have questions, just see me before class starts. I'll see what I can answer.
Okay, thank you. Bye.
Bye.